Hello and welcome to our biomechanics video. My name is Audrey Lodge.
I'm Madeline Bryant. And I'm Maddie Dustin. For our biomechanics topic, we chose ground reaction force. So the ground reaction force is a reaction force that's provided by the surface upon which a person or object is moving. There are three components to ground reaction force: the vertical component, and then two different forms of horizontal force. There is a medial lateral component of horizontal ground reaction force and also an anterior posterior component as well. The picture in the slide shows the vertical ground reaction force applied to the foot in the different stages of walking from heel strike to toe off, and the highest amounts of force are seen when the heel makes contact with the ground and when the ball of the foot also makes contact with the ground. This is because there's a smaller center of pressure and the force is more concentrated on that part of the foot. So our definition of ground reaction force is when the ground is pushing back against you with an equal force. It's what keeps you from falling through the ground because the same force is being exerted back on you with each point of contact. So Newton's third law of motion, law of action-reaction, directly relates to ground reaction forces and gives the basics of what it is. It states, for every force exerted by an object, there's an equal and opposite force on that object. An example of this is if you're pushing down on the ground with your foot, the ground is pushing an equal and opposite force back onto your foot. Ground reaction forces are also the reason why you stay planted on the ground instead of falling.
So we decided to add a video to demonstrate a practical example of ground reaction forces between a sprinter and a marathon runner to show differences between the two.
This is world champion and world medalist in the 100 meter hurdles. Running at 10.2 meters per second on the SMU high speed force treadmill. We simultaneously record ground reaction forces and video at 1,000 frames per second. To run fast, sprinter apply forces up to 500 per body weight in less than 100 milliseconds for each leg. This is the front line fastest sprint in our history. Running at 5.7 meters per second, 200 marathon pace. We have different foot patterns, lower amplitude and longer duration than sprinters. During marathon, I impact the ground 45 times a time with 3 less athletic pace for each foot. Running ground reaction forces thus have fundamental physical and biological significance. Is there an underlying principle that equates the force to the motion of the runner? There is. Newton's law of motion. We determined that the motion of the body conveys the imbalances of the foot running. Class 1 consists of the lower contacting limb. Class 2 consists of the rest of the body.
The vertical ground reaction force is the force that acts in opposition to body weight in an upward and downward direction. Body weight is gravity with mass accounted for. A person standing on the ground and not falling through the ground is an example of when vertical ground reaction force and body weight are equal, seen in the picture of the cat. An example of vertical ground reaction force being less than body weight is in quicksand, seen in the picture of Bear Grylls sinking in the quicksand. When a person or object is airborne, such as the picture of Michael Jordan dunking a basketball, the vertical ground reaction force is equal to 0 because he is not in contact with the ground. The graph in the right corner shows an example of anterior and posterior horizontal ground reaction force. The negative impulse is seen as the braking impulse when the center of mass is located behind the center of pressure of the foot. This causes friction to work against the direction of motion and slows the body's velocity down. The positive impulse is also called the propelling impulse, where the center of mass is crossing over the center of pressure. This allows for friction to work in the same direction as the motion being produced and helps to push the body forward with increased velocity. Runners want to reduce how large the peaks are because it requires more energy to balance out the negative impulse with the positive impulse. A free body diagram is used to show the external forces that are acting on a system. One external force that makes a huge impact on the body is body weight.
It is labeled by the center of mass and is in a downward motion because of its relationship with gravity. It's this force that opposes the vertical ground reaction force. And in the diagram to the left showing the runner, there is a horizontal ground reaction force being applied while friction is going in the opposite direction and opposing this force. This is what's keeping the runner upright and not slipping. Without friction and these ground reaction forces, we would not be able to run or walk. Looking at diagram A and B, there is also a vertical ground reaction force being applied to the other leg not labeled. There are two ground reaction forces when both feet are stationary because there are 2 points of contact.